Hello, this is my experience with sticky circuits, or what I'm calling STEAM in action. Some maker stuff here. My first attempt ended sadly in failure, and this really was a good experience for me because this helped me to put myself in the student's place and understand what was needed to be successful. First was that I arrogantly kind of went into this with, oh, this is a simple circuit and I don't even really have to put that much effort into it. And then I quickly realized that that was not correct. And I failed on my first attempt. And I had to then persevere and go back and think through the steps and really pay attention to the directions to figure out what I had done wrong. So that's a good learning experience because it shows me what might happen with students and some of the frustrations they might have. So then, luckily, I eventually got success, which was very simple. I just had the LED upside down. So anyway, I think also this shows us that the ability or the space to allow failure and mistakes is just fine. So I did go on to do 2 other circuits. Once you have one success, it becomes a little bit easier to be more successful, and isn't that true about everything? So I got more comfortable as I was putting the circuits together. It still took time and perseverance, and the sticky tape itself sometimes didn't have the best conduciveness when you're making bends and things. So had to keep manipulating the tape itself and also the LEDs to finally get everything to connect correctly. So that also is another thing that students can learn through this project, is that not everything is going to work exactly the way you planned it to work, and that sometimes you need to play around with things to make it work. So what STEAM skills are addressed? Well, I think all of them are being addressed. Of course, it addresses science because we're learning about how electricity is conducted, technology, because we can see how this is applied, right? The circuits that they're making, the circuits that are in your computer, this is all, how science is being applied. Engineering, because the students have to figure out how to make things work. I also find the artistry within it because while they are learning, they have the book to learn and they have the outlines, but then there's also creative projects that you can put together. And they're also included in the book too. And then math, because it is highly connected to logic and reasoning, and also a little bit of geometry with the idea of conjunction and disjunctions. How to evaluate student work? Well, I'm taking some of the ideas from the professor. Show the work, right? Explain the processes, just like we're all doing right now, and also presenting these processes to the class. The idea also to instill in the students that failure will happen, but they do need to persevere. So failure is okay, but long-term failure and no perseverance is not. As I teach older students, I would be interested in them actually completing the circuits, the correctness of what they're doing, also the neatness, because you have to be very meticulous in getting the sticky tape down just right. And we all know what sloppy work looks like, and we all know what work that is neatly put together looks like. We could also show models to the students, of course. And then also they need to follow directions. They need to follow the instructions. So there is different ways to evaluate, but I wouldn't use rubrics for that. But I would have the expectation that they finish these circuits. And finally, the way to involve all students, I think the easiest way is that students work in pairs or small groups. And having that in mind, we all know that in any class there's going to be some students who are so at ease with this type of work that they can do it with their eyes closed, and then you're going to have students that are uncomfortable with the work, or they feel perhaps that, you know, it's not something that's for them, and there could be gender issues. But I think if you can, as teachers, you know the different personalities in the class, and you can kind of pair the correct students together so that you might have a student leader, but to make sure that that student isn't taking over the entire project, and it's also involving other students, and that also includes students that have different disabilities, whatever they might be, to have them work with their other students to get the work done. And I think that would solve that issue. So anyway, I had a lot of fun putting this together, and also putting together my other project, which I'll be sharing shortly. This is really a great thing. I love how it helps map out everything, and I can really see this being very successful to teach a variety of different lessons.